Hi guys, welcome back to my channel Pirai Academy. In the series of Zoho interview question, today we are going to see about a question called find the minimum number of moves needed to move from one cell of a matrix to another cell. Okay, fine. So in this question, they will be given a matrix, okay? And in this matrix, there will be only 4 possible elements. One is 0, another one is 1, another one is 2, and another one is 3. Fine. So 0 means block. Okay, and 1 means source, 2 means destination, and 3 means it is path. We can travel among those threes. Okay, so this is the basic definition, and we want to tell them what is the shortest path or what is the shortest or minimum number of moves I can go from source to destination. Okay, for this problem, if I just go to the source to destination, then how can I go? So first of all, I will be starting here from 1 and then 3, then 3, then 3 and then to the destination. So this is one of the path, and this path's number of steps will be 4, because from 1 to 3 it is 1, then 1, then 1, then 1. So totally of 4 steps, right? So in 4 steps I can go here. What are the all another combination? So I can go along like this. So 1, 3, 3, 3 and 2. So I can also go like this. Okay, here also it is what? 4. Whether I can go any other ways? Yes, you can go. So I can go like 1, 3, then I will be going from here to here, then here to here, and then here, right? So this is also another path. So this path will be having of 6. Okay, so what is the minimum among these? 4. So 4 will be my output. Okay, you cannot move by this zeros. That's why I'm not touching these zeros. Okay, fine. Now, what is the best optimized approach, or what is the basic approach that comes into our mind by seeing this problem? So it is like a simple, right? Because as you saw this problem itself, it is clearly stating that we cannot do this without just finding out all the combinations of the path, right? We want to just go along all direction and explore the paths and find the minimum number of steps that is needed. Can you understand this? So it is quite sounds like a recursion and backtracking. So it is sounds like recursion and backtracking either by DFS or using a queue BFS. So this is what the thing that comes into my mind when I am just seeing this problem. And the problem is stating that we want to find all the combinations, right? That itself it is finished. Either it is a DFS or BFS. So if you don't know about this recursion and backtracking, just go and search in my YouTube channel. Okay, there is a playlist called recursion and backtracking. Just go and search and just find some useful videos and just learn those videos and continue with this video. Okay, I'll be giving the playlist in my description. Fine. Now I'll be starting with this. First of all, we can see the DFS solution. Let me take this array once again. Yes, so this is the array. Okay, so basically DFS stands for depth first search algorithm, right? So first of all, I will be going along the matrix. Okay, I will be going along the matrix and find where is 1 is placed, because 1 is not necessary to be placing at the 0,0 index. It can be also placed in this index or this index or anywhere. And the destiny is also not to be placed at last. It can be also placed anywhere. Okay, so it is not necessary to be in a top left and bottom right. Okay, so here this 1 is here, right? So first of all, I want to find this 1 in this. So where this 1 is present. Okay, now I found out. Now I want to just explore in all direction. What is me exploring in all direction? It means I want to explore in left, right, top and down. So I want to explore in left, then right, then top, then bottom. Okay, so first of all, I'm going to the left side. Whether there is anything? No. So I don't want to go left side. Okay, next side is what? To the right side. Okay, can I go to the right side? Yes, because it is 3. And this element exists. Okay, now from this 3, whether I can go to the left side? No, because that's the starting point. How can you go? Can you understand this? If I go here, it will be like a cycle. Okay, that's why we don't want to go here, because it is a starting point. So I will be not going here. Whether I can go to right? Yes, you can go. So go to the right. Okay. Now, whether I can go to the left? No, because this 3 is already visited. So to just make sure the current index or current element is visited, we want to make them into anything that is not in this matrix. So in this matrix, no, there is nothing like a negative number, right? So whenever I am visiting like this will be converted into -1. Once I am returning from that node or that index, then I will be changing back to its original number. I will be showing you. Just wait. So from here, I'm again traversing here, right? So it will be -1. From here, whether I can go left? No. Whether right? No. Whether top? No. Whether bottom? Yes. You have only one possibility. See, for this 3, I can either go left. Sorry, I can either go right or bottom. Both are allowed. Okay. But at first I will be going to the right. Okay. But for this 3, I can only go to what? Down alone, because left side it is already occupied. Top, there is nothing. Right, there is nothing. So I will be going to down. Okay, go down. So it will be changed to -1. Hope you understand this. Now from this, whether I can go to left side? Yes, you can go. If I go to left side, it will be changed to -1. Now from here, whether I can go to left side? Yes, you can go. If I go to left side, then it will be something like -1. For this current index, whether I can go to left side? No. Whether I can go to right side? No, because it is already visited. Whether I can go to top? Because no. You cannot go to top, because it is a starting point. Whether you can go down? No, because it is 0. So we have no option, and this is not my destiny also. So I cannot go anywhere, which means it indicates that, hey, from myself, you cannot reach the destiny. So it will be returning what? Infinity. Before that, this, let me just shrink it. Okay, now this -1 will be replaced as 3, because now I am unvisited, because I returned a value. Called infinity. Can you understand this? Okay, again from this 3, whether I can go anywhere? No. From this index, I cannot go anywhere, right? So this should be erased, and it will be changed to what? 3. So this is what called backtracking. When I am backtrack, I will be changing the value to the original value, and here also it will be giving infinity, because hey, from myself you cannot reach the destiny. It is means infinity. Okay, in question itself they will be given that if you cannot reach the destiny, you will be returning the infinity. Okay, I forgot to tell you. Remember that. Fine. Now from here, whether I can go to right side? No, because left side is completed, right? Whether I can go to right side? No. Whether I can go to top? No. Whether I can go to down? Yes, you can go. So just go down. Let me change the color so that it will be looking good. Okay. Now I can go down, right? No, it is what? It is destiny. So destiny means it will be telling like, hey, you have reached the destiny. Okay, beyond me there is nothing. So it will be returning what? 0. Fine. Now for this index, whether it can visit any other things? No, it is visited everything. So it also changed to 3. Fine. Now it will be returning what? It will be returning like if I go to the left side, what's the best possible answer? It is infinity. If I go to right side, okay, that is nothing, right? It means it also infinity. If I go to top, it is already visited, which means it also infinity. But if I go bottom, then it is 0. So I want to take what is the minimum among them. Can you understand? So I will be taking what is the minimum among them, and minimum among them is 0, and it will be returning what? 0 plus 1, 1. Why this 1? Because it will be telling like, hey, from myself you can get a best possible answer of 1. Okay, take myself and the path or moves required to reach the destiny. So the moves that is required to reach the destiny from this index is 0. So its previous index is 1. Can you understand this? That's way. Okay. Now for this 3, again, whether it can go anywhere? No, right? So it will be changing to previous state. So let me change this to previous state. So it will be again to 3. Fine. Now again, it will be returning what? It will be returning, hey, myself, I am getting a best possible answer, or minimum answer is 1. So take myself and this 1, and it will be returning what? 2. Okay. And then for this 3, for this index arrays, for this index, I finished right side. I cannot go to left side. I cannot go to up side. Now it's time to go to the down. So if I go here down, let me take white color now. Okay. If I go down here, okay, it will be again going here, and it will be again giving back the return value as infinity. Okay, and it will be going here, and this can be going to here and the top. If it go to the top, anyway, it will be ending with the infinity, because going to the top will not be leading to the destiny, right? But if I go to the down, it will be returning what? This will be returning 0, and from here to here, it will be returning what? 0 plus 1, which is equal to 1. And from here to up, it will be returning what? 1 plus 1 is 2. Can you understand this? It is a little bit clumsy, but if you just see step by step, it will be more clear. Okay. Now, for this index, what are the two possible answers that are minimum? 2, 2, right? I cannot go to the left, I cannot go to the top, which means they both are infinity. Okay, then I can get the best possible answer is 2, right? So now I will be changing this also. I will be changing this also to what? To 3. Okay, and it will be returning what? It will be returning me as 2 plus 1, which is equal to 3. Okay. For this one, I cannot go to the left side. I can go to the right side. Now right side is completed. Whether I can go to the top? No. Whether I can go to the down? Yes, you can go down. While going down, okay, another set of answer will be coming, right? So let me take that in the individual thing. Otherwise, it will be more clumsy. Okay. Now again, from here I can go down, right? If I go down, it will be changed to -1. I'll be just going fast so that I can finish this earlier. Okay. Now from here I can go to only to right side. So it will be again changed to -1. From here I can go to the top, or I can go to the right. If I go to the top, it will be changed to -1. Again from here I can go only to this. So it will be -1. Again from here I can go here. So it will be, so this will be converted to -1. Again from here I can go here. So it is destiny. So it will be returning 0. So then I will be changing here, right? Be quickly changing this. So this will be changed to what? 3 again. Again. This will be returning what? This will be returning 0 plus 1, which is equal to 1. Okay. Again, let me change this. So this will be changed to what? 3. Okay. From here, it will be returning what? It will be returning 1 plus 1, which is equal to 2. And again, this will be changing to 3, because there is no more ways, right? I cannot go anywhere. So that's why I'm changing. From here, it will be returning what? 2 plus 1, which is equal to 3. Okay. Now from here, I want to just again return back, right? Because I cannot go, sorry. I can go to the right side, right? I first explore the top. You can also just make sure you can go with any direction. Okay, that's what I just mentioned here. Like first I am going to the top, then I am going to the right. Can you understand this? It is not only like first you want to visit left, then you want to visit right, then you want to visit up, then you want to visit down. It is not like that. You can visit anything in any order. Okay, that's why I just explained here, like it is going right first, then only top. Here I am explaining right, it will be going to the top, then only the right. Okay, so that you can understand, we can just modify by using the codes, but for that entire program it will be a same order. Okay, fine. Now let me quickly finish this. Now again this will be changed to -1, and then it will be returning 0, and it will be again changed to 3, and it will be returning what? 1. Okay, and for this index, what is my minimum? Minimum is 1, right? So it will be returning what? 1 plus 1, 2. And then for this index, it will be again changed to 3, and it will be returning what? 2 plus 1, which is equal to 3. Can I understand this? Can I understand this? So from here, I can tell you that its down value is also returning what? 3, and its right side value is also returning 3. So among this, so here infinity, if I go left, if I go top, it also infinity, because I cannot go there, right? There is no indices. So among this, what is the minimum? It is 3. So this index will be returning like, hey, take myself and my minimum. So 1 plus 3 is equal to 4. So 4 is my correct answer. Can I understand this DFS traversal? Yes. So this is basic DFS traversal. But here, can you notice that we again and again visiting the same node twice? See here, this 3. We already visited this for many times. Okay. And if I just select this index is also again and again visited. Okay. Instead of this, if I store in memory, it will be time efficient, right? Okay. I want to tell you what is the time complexity for the solution. So what is the time and space complexity? So time complexity will be over 4 power n into m, because for each and every index, for this index or this index, for any index, okay, the number of possibilities or number of combinations will be what? 4 times. That's why 4 power n into m. Okay, and what is my space complexity? It will be n into m, because we are using what? A recursion stack. So this entire thing will be going through the recursion stack, right? So recursion will be also taking a space complexity. So this is my time and space complexity analysis. Okay, fine. Now the time complexity is so much huge, right? Whether we can optimize by using any other approaches. Okay, yes, we can optimize it. So see this carefully. Let me take any other color which is not used. So this purple color, okay, this purple color or this lavender color, okay. Just understand. If I found out at the first time itself what is the value of this 3 of this index, okay, if I go through this index, my minimum will be something like that. Okay, so if I first time itself found out this index, okay, then I don't want to again go beyond this, right? Normally what we will be doing, we will be just going along the way, although we already moved in those ways. Okay, again we will be moving, right? So instead of that, if I just store the result in my memory itself, then whenever it is again and again repeating, then I will be taking from my result, from my memory, and I will be just returning that result instead. Can I understand this? So let me just draw here. So first of all, I will be taking a n into m matrix, okay, inside which I will be filling all as -1. Okay, now this represent like, hey, for example, it is what? 0, 1, right? So here it is 0, 1. So this represent the answer or the minimum number of moves to attain the destination. Can I understand this? So for example, so see in this above example. So here, so this will be returning what? 2, right? So whenever I am just found out as a first time itself, I will be just updating this as what? 2, like this. Okay, when I encounter again that similar index, then I will be checking whether that index is not equal to -1. Yes, then I will be directly returning here itself. Okay, so in that place itself, it will be returning. It will be not going beyond this, like here and here, the recursion call. Okay, so by doing this, my time complexity will be reduced to n into m, because we will be only visiting each and every index only one time. So there are n into m number of elements, and my space complexity will be remaining same, n into m, because we are just going with the recursion approach and also this matrix. Okay, we additionally took this auxiliary matrix to store what are all the results that are in the corresponding indices. Once I am showing the code, this will be more clear. Okay, so don't worry. Now, whether we having any other approaches, you may ask. Yes, we have. Already I told you, whenever a case or whenever the problem is like recursion or backtracking, or it is like a combination, it is like combinations, then we will be taking what? BFS or BFS traversal, right? So let us go with the BFS traversal. So it is stands for birth first search traversal. So what is the difference between depth first search traversal and birth first search traversal? So depth means it will be starting from one point and it will be going up to the bottom. Okay, but in case of the birth first search BFS traversal, in that it will be going along like level by level. Okay, by level, like it's adjacent or it's neighbor by neighbor. Okay, once I will be explaining this, you will be clear with that. Okay, so for this approach I will be taking first a queue. Okay, what is my queue? Queue means first in first out or last in last out. Anyway, okay. Now initially I will be traversing this entire matrix and I am just finding where is my source is present. So source is present at this point, right? So I will be just inserting this into my queue, and also this is the index, right? And also I want to insert a step. So it is what? 0 initially. How many steps I have done now? It is 0 steps because it's the initial point. So there is no steps is required. And also I will be taking a visited array or matrix to avoid again visiting the same neighbor. Okay, I'll be telling that clearly once we are just proceeding with this example. Okay, so initially I will be taking all as -1. So -1 represent that it is not visited. Okay, so here I took what? This 0, 0. So this will be made as 0, which means I already visited this. Okay, now I'll be popping this out. Okay, now while I'm popping this out, I want to insert its left, top, down, right. Okay, so what is the left? There is nothing. What is the top? Nothing. What is the right? Right is we have 3, right? It is not 0. If it is 0, we don't want to just update this. Okay, but it is 3, so it is valid neighbor. So I'll be inserting this as 0, 1, what is the previous distance? It is 0, right? Now 0 plus 1 will be 1. Okay, and this will be made as 0. Hope you understand this. Yes. Now I can also go to the down part. So it will be 1, 0, 1, and this also become 0. Fine. Now in the next iteration or in the next popping, okay, I will pop this. Fine. So for this, what are the neighbors? It is this and this. So apart from that, others are 0 and null, because in the top there is nothing, right? And in the left it is already visited, because this visited array is telling what? It's 0. So I don't want to go anywhere. So I'll be taking this 2 only. Okay, first if I take this 0 and 2, then what will be the next distance? It will be 2, because here it is 1, right? So now it will be 2. Similarly here also 1, 1, 2. Hope you understand this clearly. Now again I'll be popping this out. So its neighbor are let me change the color. So now I am popping this out. Okay, this blue color. Okay, now its neighbor are either this and also this. Okay, and we can go up, but it's already visited. Okay, fine. So I forgot to include this 1, 1. Okay, so 0. So it will be wait 0. Fine. Okay. No. So for this, I cannot include this because it is already visited. This white color circle is already visited because it is 0, and we cannot go down because it is 0. So I cannot do anything. So I will be leaving as it is. Okay. Now I will be popping this out. So what is this? So 0, 2, right? So for this 0, 2, I can say this is one of my neighbor. This is one of my neighbor. So I will be including this. It will be 1, 2, so here it is 2. So 2 plus 1, it is 3. Hope you understand this. Okay. Now I'll be making. Okay, this also will be becoming 0, right? In the white color itself. I forgot to update this. Sorry. Okay. Now this also becomes 0. Okay. Now hold on. Now I'll be popping this 1 comma 1 comma 2. So which means this. For this, whether I can go to top, no, it is already visited. Whether I can go to left, no, already visited. Whether I can go to down, no, because it is 0. Whether I can go to right, no, it is already visited. Yes, because it is 0, right? So I'll be just leaving as it is. Now I'm going to the next popping. So I'll be popping this. So 1 comma 2. So this is popped, and its neighbor, what is the valid neighbor? It is only this. It's only this. So I'll be inserting this. So it will be something like 2 comma 2 comma, then what's the value? It will be 4. Okay. Then when I am popping this out, I'm checking whether this index is the destination. Yes, it is a destination. Then I will be returning the distance as 4. That's it. Can you understand this? Yes. So this is what we are going to do in the BFS traversal. And what is the time complexity for this BFS traversal? It is same as a optimized DFS traversal, n into m, because we are just iterating over the all element in the matrix, and we are not going in any recursion call or nothing. Okay. And what is the space complexity? It will be also over n into m because of this visiting array and also this queue. Hope you understand this. So this is my BFS approach. Now let us see the code. Now the first code is the DFS approach. Okay. So initially the class, and I am taking for an example input. Okay. Now I'll be taking a dp2d array or matrix. Now n is equal to m dot length and m is equal to m of 0 dot length. So it is a row and column, and then I'm going to the main function. In this main function, I will be initializing the dp array, and then next I will be just going with the 2 loops. Okay. And I am finding and I am just replacing each and every elements in the dp array as -1. Okay. Now the next thing is I'm just traversing over the entire matrix and going to find what is the index that exists 1. Okay. And in that region I will be just calling my DFS function. Okay. And I'm just returning whether it is reachable or not. If it is reachable, then I will be returning the result. Else I will be returning what? Not reachable, which means if it is infinity, which means it is not reachable, then I will be returning not reachable. Else I will be returning what? What is the number of or minimum number of steps that are required to move from the source to the destination. Fine. Now let us see the DFS method. So this is the more important logic or important code. Okay. So just see here. If I is less than 0 or I is greater than or equal to n, and j is less than 0 and j is greater than or equal to m, which means the boundary set for the I and j, the indices. Okay. If any of these condition is satisfied, then I want to return what? Infinity, which means integer dot max value. Okay. In basic int max. Right. Now if my current index value is -1 or my current index value is 0, okay, then what should I do? I should be just returning the max value. Okay, fine. If m of I and j is equal to 2, then I should be returning what? 0. Okay, and if dp of I and j is not equal to -1, then I will be returning what? dp of I and j. Fine. Now next I want to store the current index value in my temporary variable, so that after I am just gone to the entire recursion call, I want to change that particular index, right? So that's why I'm just storing in my temporary variable, and at the current index I will be making that as -1 as a visited. Okay, as a visited. Now I am going to the left recursion call like I comma j -1, which means column -1. And for right it will be column +1, and for up it will be I -1, and for down it will be I +1. So these 4 are recursion call. Okay. After this recursion call, I will be again changing my current index element value as temporary. Fine. Now int min moves is equal to math.min of just left comma right comma math.min of up comma down, which means I'm just taking the minimum among the all the left, right, up and down. Okay, and that value plus 1 will be storing in my dp of I and j if the minimum value is not equal to the integer max. If it is equal to the integer max, then I will be storing the integer max itself. Fine, because if I just make plus 1 in my integer max, it will be going in a circle to the negative int max or negative to integer min. That's why I'm just making sure or checking before I'm updating, like it is a value plus 1 or minimum moves plus 1. Okay, and at last I will be returning the dp of I and j. Okay, so this is going to be my entire function for the DFS. Let me run this. Yes, we got output as 4. Fine. Now let us move to the BFS traversal. So basically we want to prefer a Java code for Zoho interviews. That's why I'm just giving you the Java code. And I know little about the Java code, not much. I am just basically I know entire Python and C++ and C#. Okay, fine. Now here also I will be taking a class, and then inside that I will be taking just I'm taking an example matrix. Now the length it is all same, and this too it is also same, right? Because we are just taking we are just finding where is that source point is present, and at that source point I am going to traverse in a BFS manner, and if it is reachable, then I will be returning or printing the result. If it is not reachable, then I will be just printing it is not reachable, which means if it is integer max. Okay, fine. Now this is the BFS function. So initially I will be taking a visitor matrix, and then I am taking a queue, and inside this queue I am going to place like what? I am going to place the indices. Okay, I comma j, and what is the distance between them. So that's what I am doing here, and then while my queue is empty, up to my queue becomes empty, I'm going on and traversing. I'm going on and traversing. Okay, so int of current is equal to queue dot pull off. Okay, pull off. Okay, now int I is equal to current of 0 and j is equal to current of 1, and distance will be current of 2. So I'm just unpacking this. So in Python it will be more easy, but in Zoho interviews you cannot use Python. Okay, that's the tips. And in most of the time they will be just blocking that Python in your compiler. Okay, fine. Now if this any condition is satisfied, then I want to do what? Just continue. I want to skip that, right? And then if my visitor of I and j, which means the current index is already visited, or my current index value is 0, then also I just continue. I don't want to do anything, and I will be skipping to the next iteration. Can you understand this? Yes. No. If my m of I and j is equal to 2, then what should I return? I should be returning the distance. Okay. Now I want to just iterate over the 4 direction. So for iterating over the 4 direction, this will be much more easy. So this is for left side. Okay, and this is for sorry. So this is for right side, because the column will be +1, and this is for down because row is +1. This is for left side because it is -1 for the column, and this is for top because it is row -1. That's why. Okay, and here I will be taking I will be traversing over this four directions. Okay, and in this all 4 direction I will be inserting in my queue. Fine. So here also you can just make sure that you can give this condition here, this limit condition, right? This range condition inside here, range condition, and this visitor, this both condition you can also give here, like I explained in the drawing explanation. Can you understand this? Yes. Now at last I will be returning the integer dot max value if it is not reachable. Can you understand this? Okay, fine. Now let me submit this. Yes, now we got the answer as 4. Hope you understand this problem. If you don't understand this problem, or if there is any question or doubts in this code, just give me in the comment section so that I will be just clarifying this. So basically I want you to understand what are all the approaches for solving this particular problem in BFS and also in DFS. If you really like this video and subscribe to my channel. Don't skip any videos in this playlist because all videos will be helpful for your Zoho interviews. And if you want to learn more of this recursion and backtracking, you can go with my recursion backtracking playlist. It will be more useful once you are going for a big competitive programming. Okay, thank you.